There's a 9-week release, because every 9 weeks there's a new release going out, right?
So Linus does a release, just point in time. And then the merge window is considered open. And then for 2 weeks, all the maintainers send Linus all the stuff they've had pending from the last release. We have 2 weeks to add all new features. And then he does release candidate 1. From there on, it's bug fixes only for the next 7 weeks. So it's bug fixes only, bug fixes only, bug fixes. It's regression fixes, we'll revert things, no new features.
Do I understand correctly that in the case of Linux, is this a thing where every 9 weeks there will be a release?
It's time-based. So we have that 2-week window of merging all the new features to Linus that have been in our tree and accepted already and proven to work. And the window is short, 9 weeks. We used to have 3-year-long development cycles. And the problem there is, even if you have 6-month development cycles, there's that fear of, you have a feature. I want to take your feature, but it's not quite ready. Do I want to wait? And things like that. But if you know that you can get your feature in 9 weeks from now, and it's just not ready, it's not ready. The pressure is off me as a maintainer to take your new feature until it's ready.
Linux is the world's most widely used operating system thanks to powering most Android devices, servers, smart TVs, and embedded systems. But how is it actually built? Today we sit down with Greg Kroah-Hartman, a Linux kernel maintainer for 25 years who is one of the 3 Linux Foundation Kernel Fellows. In today's conversation we cover details on how widespread Linux is and why mobile versions of Linux have 3 times the lines of code as the server versions. What exactly it takes to get a change accepted to the Linux kernel and merged by Linus Torvalds himself. How the Linux kernel operates with 4,000 contributors from 500 companies per year with just email, Git, and no project managers. And many more details. If you're a software engineer, you will use Linux directly or indirectly, and this episode will help you understand why it's so widespread and how it's a lot easier to contribute than most people would assume. If you enjoy the show, please subscribe to the podcast on any podcast platform and on YouTube. Thank you. Welcome to the podcast.
No, thanks. Thanks for having me.
So I think as software engineers, we know Linux is important in the sense of it's running on most web servers that we use and run. It's a desktop OS that some people use, and it's of course powering a fork of it is powering Android. But what is there to know about Linux? How big is this thing? How complex is this thing?
Well, it's an operating system, so it's a kernel. We took over the world without anybody noticing. I joke it's Android devices are 4 billion Android Linux users out there, and they don't realize it. That's everything else is a rounding error, which doesn't make the server people happy with me. But it's true. It's in everything. It's in all the embedded devices. It's in the air conditioning units, car electric charging ports. Satellites, runs the International Space Station.
Really?
Yeah. Air traffic control for Europe and probably the US. All the financial markets. I don't think it's in the cameras that we're using. I don't know of any place that hasn't taken over. The top 5 selling laptops for the past 15 years, Chromebooks. Those are all Linux based. Not Apple, but the Chromebooks are. iPhones. So every 5G modem out there is running a copy of Linux.
Really?
Yeah.
Wow.
So now with Apple doing their new chip, I don't know if it's the new one, but Qualcomm, all the 5G modems, probably the 4G, I'm not sure, but I know all the 5G modems have Linux inside it.
This episode is brought to you by WorkOS. If you're building a SaaS app, at some point your customers will start asking for enterprise features like SAML authentication, SCIM provisioning, and fine-grained authorization. That's where WorkOS comes in, making it fast and painless to add enterprise features to your app. Their APIs are easy to understand, and you can ship quickly and get back to building other features. WorkOS also provides a free user management solution called AuthKit for up to 1 million monthly active users. It's a drop-in replacement for Auth0 and comes standard with useful features like domain verification, role-based access control, bot protection, and MFA. It's powered by Radix components, which means zero compromises in design. You get limitless customizations as well as modular templates designed for quick integrations. Today, hundreds of fast-growing startups are powered by WorkOS, including ones you probably know, like Cursor, Vercel, and Perplexity. Check it out at workos.com to learn more. That is workos.com. Well, first of all, I'm just reflecting on why I never kind of, thought about it like this, because in my mind it was always like it's Debian, Red Hat, it's on a server side, and maybe that's because that's where I actually see where it is. Now, of course, there's the I'm a Mac user, and there's the Unix influence, which is an influence. It gets pretty close, but I think it's a good time to reflect on how many things it actually runs. In terms of the kernel itself, like how large is it? And I know, for different devices, it'll be spread differently. For server-side Linux, for an Android device, it'll use different parts of the kernel. How big is this in terms of contributors, lines of code? I know lines of code is not a great measure, but it is a
lines
measure.
of code is interesting. So we have just under 40 million lines of code right now. That's a lot. That's all the kernel. That's the kernel. The core part is like 5% of that everybody runs. And then the rest of it is hardware support. Different drivers, different devices, different architectures, different chips. So your laptop runs about 2.5 million lines of code. Your server runs about 1.5 million. Servers are really easy. Those are very simple machines. Your phone runs about 4 million. Your phone SoCs are the most complex pieces of CPU and interaction out there. They're just crazy complex chips.
Why is it like? Okay, can we just pause for a second?
Yeah.
So like again, lines of code we know is not a perfect measure of complexity, but in this sense, comparing it between the two of them with the same code base is somewhat. So you said roughly, give or take, a server is 1.5 million. A phone is 4 million, like 3 times the lines of code for a phone. Why the difference? Even though I would think that the server, does all this mission critical stuff.
A server is really simple. It's CPU and a network card and storage. That's it. So SoC on a phone you have power control, you have clocks, you have 5 different buses on there talking to different types of devices. You have battery control. You have talking to your modem. You have another version of Linux in the modem. You got USB out the back. You got USB bypass to talk to the audio side. You have audio drivers. You have a zillion different clocks and PHYs and all sorts of stuff in there. The SoC, and it's an 8-core machine. There's 8 processors in that thing. Those are not trivial things. And sometimes those processors are different sizes. So you have big and little sizes, which add the complexity just for some control, for some power management. But they all run the same core of the Linux, but it's the drivers and the devices and things like that. So your Pixel phone, I look at Pixel phone, Google ships a core kernel that all Android devices pick, not hardware specific, just says ARM64. Pixel has 300 other drivers they add to get the Pixel phone working. Some of these are tiny. This is for this tiny chip, this is this tiny chip. But your phone is really one of the most complex beasts out there for software.
So is it safe to say that, the complexity and, the lines of code will to some extent scale with that has to do with the hardware, the capabilities, and not about, like how mission critical? Because of course the phone OS needs to be stable, the server needs to be stable, my TV needs to be stable. So, that's just kind of a given, right?
Yeah. Oh, and all TVs for the past 15 years are all running Linux. So that's
so my Samsung TV is running Linux.
Oh yeah. Samsung. My Samsung washer and dryer are running Linux. So your Samsung watch is running Linux. Yes. So Samsung has their own distro. All works really nice. It's all down to the complexity of the hardware. So the kernel controls the hardware. The job of Linux is to make all the hardware look agnostic to programs. So you can write the same user space program and run it on different hardware, and it just works. A kernel's job is to manage memory and devices in a common way and provide that to user space. It's not we joke from the kernel, like user space is just a test load, but it's a tool there for you to actually solve your problems. So when you're running servers, you're running to put message through and network and storage and stuff. That's your load. And that's what they're there. For a phone, you want to control a display. You want to talk out the modem. You want to talk on the thing. You want to listen to audio.
Yeah. Lots
of different things there.
And I'm just want to touch back on the kernel because I'm not a Linux developer. Like I know, I've heard of the kernel. In my assumption, it is the critical parts as you said, the thing that runs immediately, and then it will, the user space will run on top of it. But what is the differentiator? What makes a kernel? And you said it's about 5% of all of these things. How do you split this? Or is there a definition of? Again, you're a kernel developer, so I'm trying to get a sense. How can someone who let's say I'd like to contribute to Linux and understand how it is. Eventually, I'm going to figure out what this kernel is. But what is it? What makes kernel and non-kernel?
So kernel versus user space. So there's an idea. chips have a protected mode and a not protected mode.
Yep.
In a very simplified way. There's different levels of protection. So the protected mode is where the operating system runs, the kernel.
Yep.
And that is where we share all the resources. It's one flat address space.
Got it.
And we are not isolating processes.
Got it.
So a user space process then runs on top of that, and we isolate them, and they all individually think they have the whole machine, but they don't.
Yeah.
So it's multitasking. You can run multiple programs at the same time. And the kernel is there to give you memory, to give access to storage, to give access in a common way, to give access to the network in a common way, to give or provide the pipes to go around the network stack in the user space. Yeah. Some people don't like using Linux's network stack. They have their own. To provide a way for all your different mice to show up to user space in the common way. Where you know all the different mice, USB to storage devices, your graphics controller. We provide a way to make it so that user space can talk to the kernel in an agnostic way, and their stuff will just work because all the graphics work with the same interface. Yep. We talk to keyboards all the same way, things like that. So it's a commonality of providing a shim layer above the hardware. And
then, for example, drivers. Do they always live in the user space?
So all our drivers live in the kernel. So the kernel and drivers are all, Linux is not a micro kernel architecture, it's a monolithic. So the code is all in the same address space. So a bug in any one of them has a chance to take any part of the kernel down. So Linux ships all the drivers for all the architecture in one big tarball. We ship, that's 40 million lines of code.
Yeah.
Other operating systems try and go out there and had split things off. So the core of Windows is their kernel, and then you can put drivers additional on the top. We tie everything together in one big giant blob. Theirs is still monolithic. Any driver in theirs can crash the kernel within reason. In that way, we can refactor the way the interfaces between drivers and the kernel are. Linux drivers are on average 1/3 smaller than other operating system drivers because we can see the commonalities. If you send 3 different drivers for 3 kind of same hardware, well, let's combine them all, make it smaller, and refactor things and make it easier. And let's change this API.
And this has to do with the open source approach, right?
Yeah,
that you see it like.
Yeah, so we see all this common code, and we can refactor it, and we can make it better and cleaner. And we're not tied to any fixed interface. Our fixed interface is between the user space and the kernel. We will not break that. That's our guarantee. We've guaranteed it for a long, long time. And so we always want you to be able to upgrade your kernel and not feel worried that your old programs are going to crash. So you should always be able to upgrade. That's our guarantee to you. If it does break, then it's our fault. We'll regress. There are some exceptions. There's some gray areas. There's some really low-level parts between the user space and kernel that we kind of work around, and we argue about these all the time. But we never try and break user space on purpose.
Yeah.
A lot of times we do it accidentally. We'll fix it up. That's our only really rule of kernel development. Don't break user space on purpose.
And so when we're talking about the 1.5 million lines roughly per server, we're talking about the kernel.
Yes,
and 4
kernel
million,
plus drivers.
Kernel plus drivers. Well, because it is part of the kernel. And then, you have this 40 million line of tarball, and then every platform will kind of take their parts of it. They'll take, what is relevant for their use case, capabilities, drivers, other parts. Okay. And then this is why I guess Raspberry Pi. You're going to say it's going to run this running on Linux, right?
Of course. Yeah. That's Raspberry Pi. Yes, huge. Those things are everywhere. That's what's in all the electric charging stations. Those are Raspberry Pis.
Really?
Yeah, where you plug your car into.
Yeah, it's Raspberry Pis.
Yeah, those are all Raspberry.
Wow.
Because it's a really cheap industrial thing. Lots of signages now. Those are all running Raspberry Pis.
Well, I guess it was safe to assume they're not running Windows, to be fair. So
no, yeah. So the Dutch signage for the trains, those are all running Linux. Sometimes you'll see a crashed Linux machine up there.
Can we look at a specific example of how development actually flows through with a specific patch?
Before I show a specific example, so I'll say, we had 4,000 developers last year. So they make a change. So those 4,000 developers will send an email to a maintainer, and a maintainer maintains a subset of the kernel. Every part of the kernel is owned by somebody.
And then you are one of these maintainers.
So then I maintain some drivers and things like that. But then those maintainers send things up the tree to a subsystem maintainer. So like USB serial, then will get sent up to USB, and then USB will go to Linus. So it's kind of a pyramid scheme that way. We have that. And so we have like 800 maintainers, and we have the middle section, we maybe have 200 different trees there. And then in our testing environment, all those trees are tested every day. They're all merged together, and things that happen, whatnot. So we have this kind of hierarchy of developers and maintainers that way. And part of the hierarchy is the human aspect. So if I take code from you as a maintainer, I'm now responsible for it because my name's on So if it's a simple one-off or it's a simple driver that nobody cares about except you, great. I know you're the only one that's going to be affected by it. It's fine.
Yeah.
But if it's the core part of the kernel and I take changes from you, now I'm responsible for it if you disappear. So I have to trust that either you're going to be here or that I understand it good enough that I can maintain it. So part of Linux development trust or model is trust, and it's trust in human interaction. Like I will take stuff from people. If whatever they send me, because I trust, not that they got it right, but they'll be there to fix it when they get it wrong, because we all get it wrong.
Yeah.
And that's the part. So that's the trust model we have. And then we've been burned in the past by some major features were landed in the networking core subsystem a long time ago. And then once they landed and were merged and taken, the email address behind it disappeared. And the network developer said that it took 6 months to unwind the mess. So it's hard to change the core part of the kernel. For a good reason, because it affects everybody, and also good reason in that we want to make sure that you are going to be there to fix it if it breaks.
Yeah.
But for drivers and things like that, we'll take anything. Drive by. It's really simple.
Yeah.
It's very simple thing that way. But that's the hierarchy. So it flows up the tree that way.
Yeah.
So I can show that. So here is a change. So this was written by somebody named Chester. He made a change to the USB serial driver. It's an option. The chip is called option. These are a USB to serial devices. They're in modems. They're in lots of different things. There's a ton of different ones. And there's no standard for these types of devices. So you had to add a custom device ID for every single one that you want to use. It's just the way they work. So here's a patch. And here's the description of it. This is just an email.
The description here is...
There's the subject line.
Yeah, USB serial option, adding
adding that device. And then good part about, hardest part about writing a kernel change is the description of what's going on.
Really?
Yeah, I mean, the code is easy. It's the description explaining it is hard, right? You don't explain usually what it's doing. You have to explain why you're doing it. For something as simple as this, it's really easy. So this person says, this driver is part of a Cat6 modem. The product ID is shared across multiple modems. It gives a little dump of what it looks like in the device. And then there's some more information. There's a signed off by line. And signed off by is what we created a long time ago that shows that I have the proper authorship of this and ownership, and I give it to this project under the license by which the project is run. So it's saying I'm licensed this thing under the GPL. And then way down below is probably the one-line patch. This is all just...
So this is all the description.
That's all the description.
This person is giving context on here's what needs to do about the modem, the different specifications or what.
And here's the change. So somebody changed this, remove that line. The red is removed. The green is add.
Yeah.
So somebody added and had to reformat the lines based on some new ones they added. And that's it. So they had a few new device IDs.
And then there's a device ID, and then we see a few hex numbers. Those are some IDs here.
So for USB, USB devices have a product and a vendor and a product ID. That's how they're vendor and then the products. And then there's some sub device and sub product IDs. Got it. So that's what this is for. Okay. So they're saying we're just adding support for the driver already works for these chips. This chip, but we just have a new ID because a new vendor came along and they wanted to put their own vendor ID on it. So very common.
So it sounds like this change is as simple as they get in terms of the code changed, but still the description was very extensive, right?
So very extensive. Part of the description was also just here is a dump of the description of the hardware, just so that we can verify, that is going to match with this.
Got it.
So we have tools that create those things, but it's a lot of work for a 4-line change.
Well, but this is if we talk GitHub language, although I'm not sure.
No, this
will be a PR, right?
This should be in the patch itself, not the PR. So a PR would be, say you have 10 changes you want to make. So a PR would be the patch 0 out of 10.
Got it. Yeah, this is the commit.
This is the commit itself, which is a big problem of why I don't like the GitHub model, is because people don't put the changes in the GitHub, in the Git commit. No. Because the Git repo. So there's a problem. When you commit when you're looking at the repo later and you look at the change, you don't see you can't see the pull request information.
Yeah.
And it's gone. And that's a big problem, I feel, with the GitHub model.
Well, I feel this goes back to, you built the tool, or, Linux group built the tool for your use case, and you're using it the way you intend to use it. Whereas GitHub built the pull request workflows built on top of this, and it is not part of Git for whatever reason. Maybe GitHub could have made it part of Git whatnot, but it's not, right?
Well, no. So we have pull requests. We created pull requests in Linux. We email. There's Git create pull requests.
Oh, okay.
that was a good command. It makes an email.
Is that part of the Git?
Yeah, it makes an email that says pull from this repo, and here's everything that's in this repo. And when we do a merge of that, that merge commit has all that information.
Okay.
And then so if you look at the Linux kernel and you see when Linus merges in the USB tree, he sees my little message at the top saying, here's everything that's going to be in this pull request.
You got it.
And because Git is the source, and that's where all the data is, right? And so you can see that we don't have pull requests. It's not external. GitHub could change the model and put that in the merge request, but it doesn't.
I was about to say that, like, because you did it, they could do it, but it's a matter of, I guess, preferences and, yeah.
That's fine.
Anyway.
But the good thing about this is you can track any single line of code back to who made it and what they did and what was the change log, what was the reasoning behind this, which is great.
Okay. So this comes into, this person sends it to the module.
So he sent it to so the owner to this is Johan. There's a script we have that says take any patch and give me the people who are responsible for this and the mailing list. So Johan and me, I picked this because and sent it to the USB list and copies a bunch of other people that I guess they worked with and that have changed this driver in the past.
And then the copy is also done with the tool. As you said, it kind of looks to who touched this code or who might.
Exactly.
Yeah. Oh, nice.
Exactly.
This is all automated.
Yeah, all automated. We do that.
Awesome.
So that was great. He sent it, and just the mailing list has 2 copies of it. That's just because they went to 2 different mailing lists. But then they said, oops, I messed up. There's an email from the person instantly after he sent it off.
Oh.
It said, I messed up. There's an interface. Maybe it would be a good idea to change this comment. So they go and change the comment. And then they resend it. And you just send a new version. And then in this case they send a new patch or do they just add one more no, you want to have a clean commit, right? Yeah, we don't do. So here they sent a version 2 patch. If you can see that. It says version 2, right? Oh, there. Version 2.
Got it.
And then here's the same information. And then there should be some comments about what changed between the 2 versions. Hopefully. Yes, changes in version 2 from the previous one. And there's a link back to the first one.
Mm-hmm. Nice.
Very nice. So that's what we do. So we want to see the changes because, I get 1,000 emails a day. Yeah. And when I review patches and stuff, I'll review them and then they're gone because I'm reviewing the next one. Yeah. But if when you send a next version, I want to remember see what changed from the previous one because I don't want to go back and dig through all the old stuff. Okay. So they added some information to it. Wonderful. And then what happened? Johan, who is the maintainer of the subsystem, said, hey, thanks for the patch and how for documenting it. Chester wrote, hey, please apply this after a week. Mm-hmm. He said, because after a week or after 2 weeks, it's nice. Hey, what happened to this? What's going on? Johan said, you submit this patch during the merge window. I'll talk about how we do our development model, but there's a 2-week merge window for when we do releases that Linus takes all the changes from all the maintainers that have been in their development trees. We can't add new changes at that point in time. So there's a 2-week kind of blackout for new development. But this is where all the stuff is flowing into Linus for the next release. So during that time, if you send me a patch, I can't really do anything with it, but it'll stick in my mailbox until then. Mm-hmm. So this happened to hit that little window of time.
Just to understand, there's a 9-week release. Every 9 weeks, there's a new release going out, right? And then there's a window where patches are gathered.
So yeah, here, let's talk about that. So Linus does a release. Yeah. This point in time. And then the merge window is considered open. And then for 2 weeks, all the maintainers send Linus all the stuff they've had pending from the last release. Yeah. We have 2 weeks to add all new features. Yeah. And then he does release candidate 1. And then from there on, it's bug fixes only for the next 7 weeks. Mm-hmm. So it's bug fixes only, fixes. It's regression fixes. We'll revert things. And so it's no new features. Yeah. But during that 7 weeks, people are sending me new features. Yeah. So I have a separate tree.
Which is
my next tree.
You're now batching it for when the window will open.
Yeah, so we call it Next, Linux Next. So we have a Next tree where all these are merged together on a daily basis to make sure they work. Yeah. Because be prepared for Linus's next one. And then when he does a release after everything's good, we all throw things at him again in another 2 weeks. Now, Linus doesn't pull automatically from all those merged trees. We have to explicitly ask him.
Yeah.
Because sometimes our trees aren't good.
Yeah.
So sometimes, like, I maintained the TTY and serial. One time, famously, it was a mess. Our tree, it just wasn't working. There was new features added. So I'm like, I'm skipping this release cycle. I'm going to pull out some of these bug fixes and send it to you off the side and then go. But if it was like automatically being merged in, we'd have to deal with that mess. So,
well, it's just interesting because most companies, just, reflecting on, the companies that use Git, large tech companies, they often have, let's talk about native mobile development, where there is a concept of releasing every week or 2 weeks because of the App Store review process, or same with like desktop apps that you can't really just continuously release. There's usually like a build stream, but it's not necessarily there's usually an aim for something, but it's not as strict. So every now and then it would also happen that, it's just not stable enough. We'll push it back, but there is not this rigid, like clockwork. Like I think, most companies that I've seen, they just treat it a bit more flexible because, again, they come up with the thing that they're in charge with it.
Your feature you want to have added, right?
Yeah, and then as we know, when you have a milestone, like features might be cut, deadline might be moved. Like companies do that.
It's totally
but
normal.
Do I understand correctly that in the case of Linux, like, is this a thing where every 9 weeks there will be a release?
Yeah, it's time-based. So we have that 2-week window of merging all the new features to Linus that have been in our tree and accepted already and proven to work. And the window is short, 8-9 weeks.
Yeah.
And that's good because we used to have 2-year-long development cycles, 3-year-long development cycles. And the problem there is even if you have 6-month development cycles, there's that fear of, you have a feature. I want to take your feature, but it's not quite ready. Do I want to wait?
I know what
and things like that. But if you know that you can get your feature in 9 weeks from now, and it's just not ready, it's not ready. And it's much more like, okay, the pressure is off me as a maintainer to take your new feature until it's ready.
You can say, like, look, if it'll make it into the next one, or let's make sure it's going to work properly if it's more complex.
Yeah, we have lots of features. I mean, famously, there's a USB feature that's on patch version number 35. So this 20-line or this 25 patch series, it's on the 35th version, and it's just not ready. And then I just got emailed today saying, well, maybe we need to change this to this other way. I mean, so I feel so bad for that developer, but he's been working hard, and it's a complicated feature, and it's taken him 1.5 years to get there. I have other patches that are on version 3, but that's version 3, and it's been 2 years because the developer just took a lot of time in between.
Okay, so in this case, this is a good example that the person, the contributor, said, like, hey, a reminder, I'd like this patch applied,
and it's fine.
And then Johan replied, reminding of the timeline on how it works, right?
Yeah, exactly. And Chester wrote back.
Oh, and then really friendly, it'll be in the next one, don't worry.
Yeah, Chester,
which is nice, very positive.
Yeah, we're not mean people. Yeah. Oh, and then reminding, don't ever feel bad about reminding me that I haven't reviewed your patch in 2 weeks. Now, if I haven't reviewed it in 2 days, I'll be a little testy. But 2 weeks is a good idea. And then Chester wrote back, thanks a lot for keeping an eye on it. Keep up the good work. And that's it. So then Johan has it.
Yeah.
Johan applied it to his tree because he then wrote saying, hey, and Johan was very nice here. He said, you kind of didn't do the comments in the proper format. I fixed it up for you.
Oh, nice.
So for drive-by changes like that, we want to make it really easy. And we're not mean people.
I mean, clearly this feels like it's a person who is unlikely to become a regular contributor. They're getting their work done, right? They're adding.
They have a device that they have to ship.
Yeah, pretty much.
But we want to be friendly and open and easy to everybody because everybody submits their first patch at one time, right? Yeah. Famously, when I did my very first patch, I wrote an email saying, how do I make a patch? Because we didn't have good documentation. Somebody wrote back and said, hey, here's how you do it. He became my boss 8 years later. It was like, I ended up working for him. It's just funny. It's just like a small world and whatnot. But yeah, and we want to make it easy.
Yeah.
So Johan takes this and he's got the patch and it's in his tree now.
Yeah.
Which is great. So, but that's in his local little tree. Then he has to get it off somewhere else. Johan then makes a pull request to me. Mm-hmm. So this is an output of the Git make pull request. I don't remember what the actual command. And this is what a pull request from Git will look like.
And this is because Johan is a subsystem maintainer.
Yes,
and
Johan maintains the USB to serial drivers. There's a bunch of drivers for this types of things, and then he sends it off to me, the USB maintainer.
Got it.
And he says, take this patch or pull from this tree at this tag. Yep. And it's a signed tag. So it's signed with his GPG key, so I can verify that it's really him when I pull from it. And it says, take these patches and here's the information. It's going to be some USB device IDs, and they have all been in Linux Next with no reported issues. So they've been tested. In our integrated testing, we test all this stuff every day.
And what does testing mean? Is it automated testing? Is it pushing it out on devices and device labs? Is it a mix?
Yes, it's all of that. So we have so Linux Next gets merged every day. As a developer in Australia, he merges all the trees together and builds them and boots them.
Yep.
And virtual machines.
Yep.
That's a non-trivial thing for a kernel to do, is to boot. If it can boot, it's usually, hey, things are going well. It isn't testing on real devices. Yep. Now, there are other labs out there with Kernel CI, which is our CI infrastructure, that can run on all individual labs, and we do push things out there, and there are people testing Linux Next on their real hardware, sending us reports back in an automatic fashion. Those are less rare. Linus's tree gets tested more on that. The stable trees, I can talk about stable trees in a little bit, get tested more on the real hardware more. Linux Next gets build and boot tested pretty well.
Yep.
I don't run Linux Next. I run my development trees on mine, so I don't run all the mix of them all. Sometimes they interact because we don't have any fiefdoms. If I have a USB change that needs to actually go through the networking stuff, I can change the networking code and whatnot like that. And they can say, hey, maybe you shouldn't do that. And we try and get approval. You review my patches, but it's now we can touch anybody can touch any part of the kernel in a way. But he sent me a pull request, and a pull request is that I don't actually review the changes in it. I'm not reviewing each individual patch through email. I'm trusting that he sent me 4 patches here and that they're good.
Yeah.
And I have known Johan, and I know that he will be there if something goes wrong.
Yeah. And like you read the kind of the description, and then every now and then you might decide, for example, to like deep dive into a change.
Totally. I mean, for USB device IDs, it's like, okay, yeah, well, they're all touched to the same driver. Yeah, these are common. They're nothing simple. Sometimes they're a little more complex. I don't pull from a lot of different trees, but I pull from some that I trust. Mm-hmm. Some subsystems that I don't necessarily trust as well, I will make you send them an email. Yeah. And I'll actually review them, and then I'll review them. And then when I review them, I add my signed off by to it.
And I guess part of trust will be here. I'm just going to assume that since you and Johan know each other well and you work for a while, Johan will probably also every now and then give a comment saying, hey, Greg, there's this change. Can you take an extra look on this thing, etc.?
Yeah. So sometimes Johan makes changes to the code himself. Mm-hmm. Or I make changes to the code myself. I put it out for review. Mm-hmm. And I have other people review my changes.
So this is just fascinating for me to explain how trust between people, maintainers, is so important for efficient development.
Yeah, and then also the trust is, somebody once told me that Linux development was the scariest thing they ever did not because it was like difficult or whatnot, it's because my name is on this change and it's public. And that makes you as an engineer do really, really good work. Mm-hmm. I mean, so much so that this person who said this patch went back and looked at it instantly and said, oh, wait, the comment could be made a little bit better. And they're like, oh, yeah. So, I mean, that's not a normal development process in a company that commit to go.
No, it's just, it makes me, wonder about a few things that I kind of took for granted. For example, could this mean that closed source software where the outside world does not know how it's done, maybe there's just a bit less incentive to do, such great work. And actually, it's just a reflection. Like, I do remember when I worked at a company, and when my team, we open sourced a component that we built. And I just remember how I put in way more work into that to make it look good, to have the document, not just look good, but to make it clean. We cleaned up actual tech debt before we published it. And we didn't do that with our stuff. It was...
So open source development, by virtue of just human pressure, makes a better engineering product. It's a better engineering, and we've kind of shown that through the years that this development model creates a better software.
I'm kind of revisiting some of my not assumptions, but I never thought of it like this. But it's awesome to see this. So then what happens next after Johan sends it?
So Johan sends it to me, and then I take it and I put it in my tree. I think I sent him saying I took it.
And then if you take it, you're responsible, right?
I pulled it and pushed it out. Yes. Yeah. And there's my email that says that. So now I'm responsible. It's in my tree.
Yeah.
So now since this is a device ID, these can go to Linus at any time. We can add bug fixes or new device IDs. These are true. Yeah. So then a few days later, I send this change off to Linus. So I send Linus. I said, hey, Linus, take all these following changes, and here's a whole bunch of USB fixes.
Mm-hmm.
So here's some small driver fixes, some new device IDs. And then, so I summarize it all. I say, these are all the things in here.
Yeah, and these are going to be like a few dozen of patches, something like that.
Yeah, there's a whole bunch. But here's the list of the patches down below. And here's the diff stat of them. Here's the diff of them to make sure that this diff matches what he pulls from. This is signed with my key. Mm-hmm. I do say almost all of these have been Linux Next. I guess some of them slipped in. But we also have another testing. When you send patches to the mailing list, we call it a 0-day bot. We'll go through and start applying them and build testing them. Mm-hmm. And that's run. And then our own trees that we create also does verification that they did build and boot. Yeah. And it will run some benchmarks. For drivers, it doesn't really run benchmarks. Yeah. And so then Linus takes this and he puts it in his tree. And so then it got picked up. So it got picked up another day later. And then let's talk about how we do our model. So Linus does a release every 9 weeks. Yep. Bug fixes come in during those 9 weeks for the last release. You're running the last release, right? You want those bug fixes. You had a device that's running those bug fixes. A long time ago, we realized that people don't want to wait 8 weeks. So let's create a model of, we have a development tree and we have a stable tree. Mm-hmm. So when Linus does a release, I fork off Linus's branch and I say, this is the stable branch. So if 6.4, I do 6.4.1, .2, .3, .4, .5. Mm-hmm. And our release numbers are just numbers. They mean nothing. They're not semantic versioning. We were around way before that happened. They're just meaning this number is later than that number. Yep. That's all. When we switch from 4.x to 5.x, it's just because the x got too big. Yeah. And in your brain, when you see a number between like 14 and 18, it looks smaller than 4 to 8. Yeah. So, and it's just, so we just bump it up every couple of years. So then we take stable. We have stable releases. I do a release every week. And what I do is the patches have to be in Linus's tree first. We can't diverge. Mm-hmm. So if it's in Linus's tree first and it's a bug fix and it meets this criteria, I put it in the stable tree and I do a release. And so we do new releases every week for that. So during those 9 weeks, I'll take new device IDs. I'll take bug fixes and whatnot. And then you can tag the fixes that are going into the tree with a special way that I'll automatically take them. I know to look at them. The other stable tree maintainer with me, Sasha, he runs through them and runs a whole bunch of fuzzing. He's been doing AI before it was called ever AI. It's just pattern matching. Mm-hmm. I mean, and we have a whole body of, here's a whole bunch of bug fixes. Here's a whole bunch of changes. Did anybody do these kind of match? Oh yeah, these people. So some people don't realize that, this was a bug fix. It should go into the stable tree. Mm-hmm. They've written academic papers on it for years. It's fun stuff. Wow. So just pattern matching, right? Yeah. So they'll pick up a whole bunch of stuff that, hey, maybe you forgot about that. And you'll give you a chance to respond before it goes into the stable tree. And we do those releases. When Linus does a new release, then I throw that stable tree away and I make a new stable tree. Mm-hmm. That's great for things that it can update more often. People want to make a device. You want to make something that's going to last a long time. So what we come up with the idea is long-term stable trees. And there I pick one kernel a year and I maintain it to start with 2 years, sometimes 6 years. Mm-hmm. So your Android phone is running off a kernel that's 5 years old, but it's still getting bug fixes back to it. So I maintain like 4 long-term stable trees at the same time. Mm. And we backport all these fixes to all the different branches, and then we pick one a year and we maintain these. So there's 6 of them going at a time.
And in this case, like, is it you, like, there's one maintainer for each of these long-term?
No, it's just me. Me and Sasha.
Yes. Wow. Okay.
Yeah, it's the two of us. The interesting thing is the older the code is, the harder it is to maintain. And the companies like, I'll put a junior developer to maintain old code. That's harder because it's more diverged from what the latest developers are using.
Can you tell me a little bit more about this? Because, the older the code, the harder it is to maintain. Like, I think it feels true, but why is this the case? Is it just lost context?
So development moves on, goes forward, right? Yeah. So say a change I make today to the code base, it fixes the bug that affects the code. That I look back, it's affected the code for the past 10 years. Yeah. All right. If I try to start backporting this change to code that's 10 years old, code has evolved in that time. Yeah. And making that change to older code is harder. And the more I have to change it, the more it diverges from the original fix. Mm. So the more context and skill you have to make the change to the older code base than even the developer who made the first change. It's not intuitive. Companies make this mistake all the time, thinking, oh, I'll just maintain this old code base for a long time. We have major security bugs like Spectre and Meltdown with chips.
Yeah.
Some of those Spectre fixes have not been backported to some of the long-term kernels that are still being supported because it was just too hairy of a fix.
Yeah.
And anybody who cared moved to a new kernel.
Yeah.
So I look at a lot of these older kernels it's again, if you're using it, you will provide the resources to maintain it. Google, I'll call out, and Lenaro, Google's another group, do a lot of work in testing these old kernels because Google cares a lot about these kernels.
Yeah.
So they provide testing infrastructure and merges and reproducibility and running on real devices to make sure that these kernels still work on them and they work well. And that way I know that if I make a change back there, it'll still work. And if I didn't have that resources for them doing that work, I wouldn't be able to maintain these old kernels.
Yeah. And then going back to the bug fix, so like every week there's a new stable branch release. Mm-hmm. And then when does the big release come, the 9-week release come? That's after this has been kind of baking, right? For the stable branch has been...
Well, so stable's independent of Linus's tree.
Oh, stable's independent.
So
okay.
The only tie is it has to be in Linus's tree first. We do not want divergent. We don't want you to make a fix to a stable tree only in non-Linus's tree.
Got it.
So sometimes I will have bugs in the stable tree due to other changes I've taken. I mean, fixes need fixes. And I'm like, I can't take the fix for this until you get the fix in Linus's tree. And it's kind of a forcing function on a developer to get a fix to Linus before I'll take it for the stable tree. And sometimes I'll revert the change in the stable tree.
And do I understand the way to get a fix into Linux is of course, you need to get a fix into Linus's tree, which means you need to go through one of the maintainers who is in, who maintains one of the subsystems.
Yeah, so say...
And you just need to go up the tree, up the pyramid.
Right, so famously, Bluetooth always breaks every other release. Bluetooth is crazy complex, the hardware is horrible. And if you need to get a fix in there, it has to go to the Bluetooth tree, and then that gets sucked into the networking tree, and then that network tree goes to Linus. So it's like a 2-stage process. Sometimes, and then we have somebody tracking regressions. Regressions are really important. We don't want anything to regress. Sometimes Linus will say, I'll just take these bug fixes or regressions. I'll just take them now. Boom. I'll just take them. So depends on what they are. If they affect hardware that's really common, we prioritize that over hardware that isn't as common just by virtue of, hey, this broke my laptop. Right. I want to keep working. So yeah, it's a little thing that way. So we have 2 branches going at once, development and then stable releases happening.
Okay.
So then this went into Linus's tree. I picked this out as part of the stable trees, and then they ended up in the stable tree somewhere as well. And then I can give you dates for all this stuff. This whole process took about a week and a half. Mm-hmm. And that was it.
Okay.
And then it ended up in the 6.13.4 kernel as well.
Yeah.
And then and other ones as well. Back to.
Trust isn't just earned, it's demanded. Whether you're a startup founder navigating your first audit or a seasoned security professional scaling your governance risk and compliance program, proving your commitment to security has never been more critical or more complex. That's where Vanta comes in. Vanta can help you start or scale your security program by connecting with auditors and experts to conduct your audit and set up your security program quickly. Plus, with automation and AI throughout the platform, Vanta gives your time back so you can focus on building your company. Businesses use Vanta to establish trust by automating compliance needs across over 35 frameworks like SOC 2 and ISO 27001. With Vanta, they centralize security workflows, complete questionnaires up to 5 times faster, and proactively manage vendor risk. Join over 9,000 global companies to manage risk and prove security in real time. For a limited time, my listeners get $1,000 off Vanta at vanta.com/pragmatic. That is vanta.com/pragmatic for $1,000 off. So we saw how what it takes to get a fix into Linux, and it actually wasn't that complicated.
No, it really is. I mean, it's just you email a change off. And
you email, you use the Git workflow. If you're familiar with Git, it's pretty simple. Obviously, I'm assuming obviously you need to be able to build Linux, test it yourself, validate locally that it works, the basic things, and then it's straightforward.
The fun thing is, so I can take a change like that without really testing it because it built. It obviously works for your hardware. I didn't test it, but it works, and I assume that it goes.
Yeah.
And it's very fast workflow as far as getting a project. So it was like a 2-week window from sending the first change, that was the merge window, to getting it out into stable kernels to the world. That was pretty fast for overall for a worldwide project that is everywhere.
So I think I understand what it's like to, be someone who contributes to Linux every now and then. But over time, so some people start to contribute more. They become more regular contributors. And eventually, you're one of the few people or one of the few or many people who works on Linux full-time. Are there many people working on it full-time?
So Linux has almost always been paid to be worked on. So I started keeping the numbers back in 2006 or something. And at that point in time, 80% of the people that contributed were being paid to do it full-time for their employer. And their employers want people who know how to do Linux because they want to solve their problems. Yeah. They want Linux it's much cheaper to pay a few engineers to add a few new features than it is to write your own operating system.
Fair.
That's the beauty of Linux. That's why IBM put a bunch of money into it. That's why everybody uses it. It's a tool for people to get their work done, right? You want to run your battery. You want to run your car charger. You had a little driver for the one device you had an engineer do that, and it's good to go. And it'll be maintained for forever because we maintain it in the community. It's all good. So it's cheaper. So we've been doing it. And the joke used to be you get 3 changes into the kernel, you get a job. It's not really a joke, as long as they aren't spelling fixes. But some people do spelling fixes, which is great. We have people that do janitorial work to the kernel. They sweep the tree for common problems, and they just clean stuff up and keep code alive and make sure it's fresh, proper coding style. We have coding style issues. We have people just fixing spelling mistakes and comments, which is great because you got to start somewhere. And in fact, spelling mistakes and comments is a great place to start. Because it makes you get the workflow down. You figure out how to make a patch, figure out how to send an email, fix your email client to not send HTML and things like that. Yeah. And you can't use a web client. Web email client to send an email. It just doesn't work. Good email. There's lots of really good email tools out there. Use them.
But you're now a full-time kernel.
I'm a full-time maintainer.
Kernel maintainer. What does your kind of day-to-day or week-to-week look like? Because I'm going to assume it's going to be a little bit different than most developers who, write code, review code, do those kind of things.
So, I've been working for the Linux Foundation for 13 years now. Before that, I used to work at Novell and SUSE, before that IBM, and then a little startup, all doing Linux stuff all the time. And then before that, I did embedded work. When I worked for a company, you end up working on features that your company wants or reviewing code from the other developers of your company and then sending off changes. Or if you're a maintainer is, and the networking maintainer said this the best, we're like editors. We used to be a writer. All we do is critique other people's stuff now. But because we were a writer, we have a little side project. So we do have little things that we do, dabble and stuff. So I did 80 changes, only 80 changes last year because I had a few little things I want to do. That was low. But working for the Linux Foundation as a full-time maintainer, that's rare. I think there's only maybe 5 people, maybe a handful of people that just work on whatever they want to do. Mm-hmm. So Linux Foundation rule is they can't tell me what to do and I can't tell them what to do. Works out great. Me and Linus and Shuah, we're all fellows there, and we work on improving Linux for however we feel like it. Me and Linus do a lot of review, a lot of other stuff. Linus still contributes. He famously rewrote the core locking primitives in Linux a couple years ago. And I had a Microsoft developer say, there's no way any of us would be even allowed to do that on Windows. You don't change core bits and pieces. For one of the security features and one of these stable releases, Linus had to rewrite the call path from how a user space calls into the kernel, the core syscall path. Nobody really noticed that it got rewritten, but it did, and he did it and in a stable way, and then it works like that. So we're also part of this the kernel security team. We get security bug fixes all the time, and if they're easy, we'll just fix them ourselves and send out the fixes. So we do security fixes a lot as far as that goes. So my day-to-day is I read other people's stuff. Like I said, I get 1,000 emails a day to do something with. You're
not aggregating.
No. Yeah.
You get 1,000 emails a day.
Yes.
Wow.
So I don't have to, a lot of it just file off and it's like, this, like I subscribe to a number of kernel subsystem mailing lists to see what's going on.
Yeah.
And I don't have to do something with all of those.
Yeah, but some of them you need to do something
with. Some of these I do need to do something with. And some so say for USB is one of the subsystems I maintain, I show them all off to a mailbox, and then once a week I'll go through them all and say, okay, let's review all these.
Fair.
And so I'll look in my inbox, I'll have 200 USB emails to patches to go through, and other people review them, other stuff like that. And okay, this maintainer said this was good, not good, whatnot. And I apply them to my trees, see if they build, if they failed. I'll report those and whatnot.
You know what you're doing reminds me a little bit of when I used to work at Uber. We had this concept of RFCs, which I think got inspired by the RFC process. So people would just send off a document of here's what I'm planning to do, and there would be mailing lists for like back and mobile, the different parts. And I noticed after a while that the more tenured engineers and the more experienced engineers would spend increasingly more of their time reading through these things, critiquing, giving feedback, giving pointers, connecting the dots. Yeah. And like it just hit me when one of the first mobile engineers at Uber was telling me that he has one day blocked out per day just to go through all of these things, which again, it wasn't kind of part of his role, but he felt responsible. He had all the context. He actually helped so many people avoid certain things just by pointing it out. It's just interesting how it's the same thing, or something similar happened here.
It's the same, but we also, the different part of this, and I'll call this out, we don't have grand proposals sent to the kernel list. We don't say, hey, wouldn't it be great if you did this?
Yeah.
I don't want to see that. I want to see code that works.
Mm-hmm.
And
I love it.
As proof, then code that works matters is because you've taken the time, you've proved that this can be done.
Yeah.
Now, not necessarily that it's done right or done the best way, but it could be done.
Yeah.
And that's now you have the skin in the game, and now I'm willing to work with you, and let's go on that. People do send off RFCs of patches. If it's an area I care about, I'll look at it. Sometimes you can get away with this. This is a fun trick with maintainers. If you send me a patch set that solves your problem in such a way that it's horrible, that I hate it so much, that I'll rewrite it myself. Because it'll be like, I can't say no because it solved the problem, and I want to solve your problem. But if I don't say no, then I have to take that. So you can do that like once a year to a maintainer.
I sense that you're eliminating busy work, because I've seen at different companies, when you have the proposal process, again, a lot of companies it sounds logical. Instead of starting the work, instead of investing time, maybe we would all save time by do a little planning up front, right? But then every now and then what happens is you get into this never-ending planning. Nothing happens until either the project is abandoned or someone just sits down, writes some code, and kind of, just cuts all the discussions are done because now it works.
Yeah, well, you have to prove that it can work. And so inside companies, I'll say we did like when I worked for companies, IBM, it's like we had planning, okay, we need to implement this feature to match this parity with this old version of Unix. How are we going to do that? Let's figure out how to do this. Is this going to work? Yada, yada, yada. And we have planning, things like that. One of the fun things is when you're dealing with open source, and this happened at IBM, engineer over here was tasked with fix this problem. Great. He came up with a solution, submitted all the changes upstream, lots and lots of discussion. Turns out his solution was not very good. Somebody else saw that it was a problem, rewrote it, submitted it, and got it accepted. But it wasn't the original engineer's work. Mm-hmm. And so the end of the year came. It was like, how is this person going to be reviewed? And we're like, he caused the feature to get done. It wasn't that his code made it in, but he influenced the community and the goal was you wanted to see Linux support this, right? Yeah. Linux supports this now. And it had a change in mentality of how management had to treat engineers. And also the same thing with who owns the code. We had people come in and end up becoming maintainers of certain subsystems. And that's great. And they were maintaining this part of the kernel, and then they were reassigned to do something else within the company. It's like, oh, that's great, but you're going to still have to give them time to do that other thing. It's like, no, we'll reassign it to somebody else. It's like, no. The community gave that to him. It follows him. If he goes to a different company, it follows him. He goes to a different part of the company, it follows him. And that's actually why Linux is so good, I think. When you work at a big company, you're forced to work on new things every couple of years, right? Yeah. And that's part of moving up in a company. You get different tasks and whatnot. Famously, Windows has had like 5 different teams work on their USB stack. Linux has had one team work on their USB stack for 20 years. And then we know this stuff and we have this development and depth there.
We just keep coming back to, like, I was kind of expecting a little bit of a discussion about, I came in here just, using Linux or indirectly using Linux a lot, but not knowing of the depths. And I kind of thought that we would talk a lot about the tech, the processes. And every time we come back to the people, the trust, and I wanted to ask why you think Linux has won so big that it's everywhere, but I'm starting to get the answer to this. Like because I was thinking, why Linux? Why not a commercial? If I naively asked myself before this conversation, like, we have 2 teams. One is commercially funded. They're selling their software. They're paying the developers really well. and then the other one is giving it away for free. They figured out a model where people are still paid, but it's open source. Anyone can use it. Anyone can contribute. Which one will win the long term? I naively would have said maybe the commercial one, because they're incentivized. They're going to, create all these professional things, where here it's more intrinsic value. But now
it is interesting. But so Linux has been contributed to by companies in their own interest. So it turns out everybody contributes in a selfish way. We want to solve my selfish problem. But it turns out everybody has the same problems. So your problem being solved is the same problem as their problem. Famously, we had this when it came down to embedded. So embedded happened. They came up saying we need to change Linux to make it work better on batteries. Power is really important. Power is very, very important.
A lot more efficient.
Yes. Yeah. So this was when Linux was first getting into embedded, and we need to make this very efficient. And we're like, great, that's a wonderful little solution. Make it work for everybody. No, we just care about embedded over here. That's the only person that's going to care about power. It's like, no, you really just make it generic. It'll all be good. Turns out data centers save billions of dollars in money because of power management. Yeah. And it turns out everybody, so the mainframes.
If it's more efficient on a mobile phone, suddenly it's a good candidate for it to be a mobile OS.
Yes, it works for everything. Same thing for multiprocessors. Multiprocessor came out, we have two processors in the big data center. Who's going to care about that? In your pocket now you have 16 processors. It just works for everybody now, right? Trends shrink, go different places, but because we solved it in a generic way, we forced you to solve it in a generic way, but you contributed in a selfish manner. And that's a good way that IBM knew they could put money into it, hire developers, and get the money back.
Yeah.
So it's cheaper for them in the long run to do that.
Yeah.
And they make money selling support and selling hardware.
Yeah.
Red Hat makes money selling support. And that's like that. Yeah. Intel makes money selling chips. And that's who contributes to Linux, is the people who they want to sell a different product.
Now, one other thing that's interesting about efficiency, we have 4,000 developers contributing. Some of them only contribute one change. Some of them contribute a bunch. 300 to 500 companies per year. We're talking about per year. Now, if you told me this is inside a kind of commercial company, a tech company, I would assume that in order to make this work, for 4,000 developers, we probably need to hire 400 PMs. We'll have about for every 50 developers, we'll have about 80 TPMs. We'll have director of project manager. We would have a lot of people. This is how it would run. You're laughing.
Very true. No, I know. I've been there.
You've been there, but I only come from here. Now, one thing you told me, because I was asking you how many project or you very technical project managers you have, and you said 0.
Yeah.
How?
Well, so in a way, the project managers already happened on the back end before the patches got to us. So at a company, say IBM, I want to solve this problem. They've said, how do we solve this problem? Let's put this task, let's figure this out. And then the patches come out to us. So we don't see that. So we just see the feature when it lands on us.
That's fair.
So they're there working for the individual companies to get their thing. Sometimes they're not. Sometimes they're just developers are spitting things out, and this person who needed to get a new device ID, they knew it'd save their time and money. It saves company time and money if they contribute their changes upstream than to keep it as a fork, because they have to keep maintaining that fork. So wise companies have realized, let our developers work upstream, do what they need to do there, with limited project management, and it just works out better. And again, we're only taking things when they're ready. Right now, we're not having to track. Yeah. We do have tools. We set everything through email. We have tools like the networking subsystem has a web page you can go to see what the status of your patch is, if it's passed all the CI, if it's been reviewed by the maintainer, and things like that. So we have a bunch of automatic tools based on top of email that'll help you out. And those project managers can go look at those if they want to wonder what the status of their employees' patches were at, things like that. But yeah, it's a different model, but it's not like they're hidden behind the solution for that company.
It's fair, and I think it's also good to remind that that's the case. But I feel Linux still figured out a way to just focus on just rootless efficiency with automation, with focusing on the work when it's done. So as you said, all these things do happen, but they happen before, and then you can this part of the process will just be more efficient by design.
Yeah, and but once a year we get together, the core maintainers, and we talk about not technical things because we can't have enough technical people in the room for a topic. We talk about process. Is our process working? Is it not working? And we refine it and say, maybe we need to do this a little bit better. Wouldn't it be nicer to do this? Hey, we need more testing over here. Hey, can we do this type of stuff? So we talk about our process all the time. And famously, the lead up to that meeting, is another public mailing list that we all talk about processes. And that process, that once a year bike shedding of our process in public, it helps shake out a lot of things and work out. And there are problems. I'm not saying this development model is perfect. It works really well. One thing that's odd about Linux is that we keep going as fast as we are. We're running at 9 to 10 changes an hour. In the stable kernels, we're running 30 to 40 changes a day. 10 CVEs a day. The CVE at our level, a bug at our level is a CVE almost.
Yeah. So CVEs are the critical.
Yeah, it's a security bug. So it's a vulnerability. They could be as stupid as a memory leak somewhere, or I rebooted the machine, or I took over and got permission. I don't know when I create a CVE. I don't know how you use Linux, so I can't tell the severity of it. But I can just say, here's a bug. You should look at this. So we're responsible for that. So we're running at a huge rate of change. Most large software projects have a huge ramp up, and then they plateau with developers and rate of change and whatnot because they've solved the problem. Linux has never solved the problem. And I had a manager at IBM every year. He'd come to me and said, hey, is Linux done yet? I was like, no. And it took me 10 years to finally come up with the answer of, it'll be done when you stop making new hardware. And when they stop making new hardware or having different work classes, then we'll stop. But we're one of the few projects that keep having to add new features because of new hardware. We're not doing it just because Linux has been working for all of us for 20 years. We're doing it to support new hardware, to support new use models, to support things. We don't add things for fun, generally. We add it to solve a problem that somebody had.
Now, most of Linux is written using C or C++, right?
No C++.
Just C.
Yeah.
And I guess for some hardware drivers, is there assembly ever involved or no?
No, assembly will drop down into the early boot of a processor, and then some core functionality like locking and that drivers or other people will call will go down, like string functions and whatnot will go down to good assembly language that's tuned for the different processors. Also, when you boot, Linux looks at the processor you're running on, patches itself to figure out the best functions that those assembly would work, and then it continues on moving, which is crazy. It patches itself at boot time.
So hold on, but some of that is assembly, or is
some of that's assembly in the very beginning, and some of those low level functions. But drivers don't ever touch assembly.
Okay, so basically, like from a Linux computer, it's all C. Now, one thing that actually the way we started talking is there is a proposal to introduce Rust because it's just more memory safe. It's also a language growing in popularity, and some people would like to do more Rust development. What is your take on this? Do you think Linux at some point might support Rust, or what is your thinking of doing things outside of C?
So we have 25,000 lines of Rust in the kernel already.
Oh,
we do.
Okay, awesome.
Yeah. So most of that is just bindings. There's no real functionality. In the latest release, if the kernel crashes, it'll put up a QR code. You can take a picture of it to get the crash dump. That code was written in Rust.
Oh, nice.
That's in Rust. So the Rust for Linux developers has been working for a long time. A couple of years ago, they came to us and said, we think we're ready to do this. Do you want it? And we said, yeah, let's try this experiment. You're willing to do the work? Who am I to tell no to? It's
classic Linux.
Yeah.
Right?
It's now the problem with Linux and Rust is, it would be easier to write a core piece of Linux in Rust than it would be to write a driver. A driver is consumed from everywhere in the kernel. So you want to talk locking, you want to talk input and output, you want to talk to the driver model, talk to the USB port, all this stuff. Drivers can be really tiny because they take resources from the rest of the kernel. In Rust, you need to have a binding between the C code and the Rust code. There's an intermediate layer. The kernel in C has these very opinionated ideas of how it handles objects and how it does memory and how it has its memory model. Rust has its very opinionated model of how it does this same idea. This meshing is tough. This meshing is also the most crazy complex Rust code you've ever seen. So from a new Rust developer like me, I can barely read the bindings, but I trust other people are doing it. So the trick is we now need to write a binding for every different part of the kernel in order to write a Rust code, a Rust driver. If you want to do the QR generator, that's simple. That was this one function.
Yeah.
So over the past couple of years, people have been write bindings to try and do things. We've had a bunch of example drivers, like a new disk writer driver in C versus Rust. It turns out there are still some performance issues with Rust code versus C code because we can do some tricks in C that they can't do yet in Rust.
Yeah.
That's on the tooling, and the Rust developers are doing it. The core Rust developers in the language, some of them are Linux kernel developers. They've always wanted Rust to be working for Linux. The Rust model is good. Memory safety at our level does not mean that you can't crash the kernel. You can still overwrite things. Memory safety in Rust just means the memory that you pass around, you think you have an ownership of, or it isn't an ownership of.
Yep.
And when things go out of scope, they'll get cleaned up properly. So I've seen every single kernel bug for the past 18 years. Half of them will be fixed with Rust. It's just going to be fixed with Rust. It's the stupid one-off bugs. It's oops, I overwrote an array and I didn't realize it by one. Oops, I forgot to clean up this error path.
Yeah.
I forgot to unlock this lock. It's stupid little things like that. There's logic bugs, of course. You can write logic bugs in Rust.
You'll always have those.
Right. So, but famously, the QR code that did in Rust that made the QR, C passed into the Rust code a pointer to a buffer and the buffer size. The Rust code forgot to look at how big the buffer was, and it scribbled right over memory. So you can write memory unsafe code in Rust just fine, and you can crash things in Rust. So memory safety here means it's the safety of object life cycles and things like that. It doesn't mean it's going to remove all bugs. It's not a golden bullet or anything like silver bullet. But I think Rust needs to come in because it should be easier to write drivers in this stuff. We have a lot of issues with lifetime rules of when you yank out a device, devices are dynamic, and dealing with these reference counting of things like that is very tricky to get right. There's parts in the kernel we still do not have it right, and we know we don't have it right. Yeah. Rust is forcing us to actually document our C code better. And it's cleaning up. So if Rust disappeared tomorrow, I've had to clean up code in the driver core. It's like, oh yeah, I guess we can do things better and safer in the C code in order to make Rust easier. And we have. And so it's making us rethink how we do a lot of our existing code in the kernel. To be fair, a lot of core kernel people are pretty resistant to that. They don't like change, don't like different languages. Yeah. One core kernel developer said, I don't like working with a project that has multiple languages in it, just because it's tricky. And they are free to do that. They're not stepping on anybody's toes. A lot of it's miscommunication, and a lot of it comes down to people again. Yeah. Famously, in this binding, I wrote the driver core many, many years ago of how drivers work in the kernel. There had to be a binding for that in Rust. This code I saw, I said, this is horrible. This isn't going to work at all. It's miserable. And I went and actually met with the developers. And there's a Rust Linux conference. We sat down. I think they gave a whole presentation just for me. Turns out I was wrong and they were wrong. We both were wrong. Yeah. And they were doing crazy things like they had 1,000 lines of Rust code that I do in 2 lines of C code. I'm like, well, why? They're like, well, we didn't want to change the C code. I'm like, we can change the C code because I just did that because it was easy in C. But if I change that, you get rid of 1,000 lines of Rust. Let's do that. And again, it comes down to, okay, understanding what your problems are, understanding what my problems are, and let's work together. And now we have bindings in the kernel that you can actually write some drivers with. And the Red Hat developers are starting to write the new NVIDIA GPU drivers in Rust. And they're starting to put the proposals out there. The Apple GPU drivers are for the Apple MacBooks are written in Rust. Those patches are not merged, but they're written in Rust and improve on a fork. That works great. There's a whole bunch of crazy object lifecycle issues with graphics drivers, and Rust makes it a lot easier for them to do. I think you'll see a lot more of the simple, stupid drivers for hardware devices being written in Rust because all I want to do is read and write to some random memory bits. And it's really easy to do that in Rust, and you can do it in actually less code than you can do it in C code. Yeah. And I think that's good. We now have the infrastructure in there, so I think we've hit the tipping point. We'll start seeing new stuff in there. And we need to do that. I mean, there's mandates from governments that you can't use memory unsafe languages like C in products. Yeah. And if I want to see Linux to succeed, which I do, we're going to have to change. And I can say, going forward, if you want to write in Rust, you can write in Rust. Now, that being said, we still have 40 million lines of C code. Yeah. So we have some very, very good developers out there working on mitigating the problems we have in C. Yeah. We now have bounds checking for our stuff. We now have we call them seatbelts and airbags that protect your C code from doing stupid things. And we're working with the compiler authors to add new extensions to C and make things safer for the C code because we want to protect the code that we have today because you're not going to rewrite code in Rust. Don't worry about that. Google famously published something recently saying over the past couple of years, we've written our new code in Rust and we got overwhelmingly more secure because we didn't touch the old code and bugs degrade over time. There's still going to be bugs in the older stuff, but most bugs happen in your new code, not in your old code.
That's awesome. I'm sensing you're excited about Rust, and it's also just nice to see the evolution.
Yeah, it's evolution, and see what happens. And if it fails tomorrow, we can rip it out and whatnop. But we have developers willing to do this work for us. Yeah. It's not intruding on other people's stuff.
Well, and I think it does go back to what you said earlier. I understand that a big part of Linux is like show the work. Like if it works, and same thing. It sounds like that's how Rust started, and it's also how it's progressing. People are showing that it works. So they're proving that it works. It solves their problem. Yeah. It maybe even works better for them, and then step by step.
Yeah, like people are like, well, why not Zig or Hair? Those are other good languages. I'm like, that's great, but nobody's proposed that.
Yeah.
So yeah, they want to do that. And fair, I think those developers who work on those languages don't care about Linux, which is fine. They don't have to.
So looking ahead, outside of Rust, what are other things that you're kind of excited about that's coming in Linux? Either projects, changes. I don't know if we haven't said LLMs except for once here. I don't know if that, for example, like will LLMs have any impact on how development is done?
No, there's not. I mean, they're all trained on Linux kernel code, and so you write out another driver. But LLMs are great for writing boilerplate code and things like that. Yeah. In Linux drivers, you don't have much boilerplate code because we've stemmed that down into the core and made that work better. LLMs are used to find bugs and find the bugs fixes to match that we should be taking. So but again, we've published papers on that for 8 years. There's been lots of research on that. So we've been using that for a while. I mean, LLMs just applied statistics, right? So it's just pattern
pretty
matching.
much.
So code for us at this level, it doesn't matter that much. So no. And then as far as, I don't know what's coming tomorrow because I just see what people send to me. So we don't have a plan. I mean, we always joke, Linux is an evolution, not intelligent design. It's just whatever shows up, right? Because you're solving your problem and we'll figure out how to fit it in there with everybody else's stuff and make sure it doesn't work out. People are working on new features. I mean, people are like, oh, it's an old model. It's the old Unix model. It's like, yeah, we can run code from 20 and 30 and 40 years ago. But we can also run new stuff. We have new features. We have new I/O paths that are even better. We have new types of functionality. We have new security models. We have new capabilities. We have new types of stuff for the new stuff. But we didn't break the old stuff. So we can do both stuff. You can rewrite your code. I know the databases are rewriting it to use IOU ring, which is a new way to do I/O, which gets the user space to kernel boundary out of the way and does faster paths. So they're speeding up the databases by porting to new Linux features. But their old databases still run just fine. And so it's like people look at it like, oh, nothing's changed because the old stuff still works. That was the goal. The old stuff still works. So I don't know. And just see what new hardware features. I see the new hardware coming all the time. We get told by the CPU vendors, like, look at this new chip. It's like, great. But so that's always fun.
And then in terms of contributing to Linux, we just went through this example and it seems pretty easy to contribute, honestly. Yeah. Like, I wanted to ask on advice to contribute, but my sense is just do it. Like it's not that difficult. But from a professional point of view, like what do you think a developer who, is building other stuff at a company, what would they get professionally out of contributing even one change or a few changes to Linux? Like, how could their outlook change or what could they learn?
Well, that's the best thing is it's your resume. So I talk to college students. I talk to college students at VU, other universities all the time. Say, hey, contribute to the kernel while you have time. And then when you go to get hired, somebody can look at you and say, oh yeah, look, you do play well with others and you did contribute to other stream. Because when you come in as a company, you're not writing code from scratch. You're working with other people. You're working with existing code bases. Yeah. If you contribute to Linux, or any open source project, you show that you can work with others. You can work with the existing code base. So it shows a great skill set. When I hired people when I was at IBM, if you contributed versus not, it's like, oh, that's an easy sell. Mm-hmm. I'd rather take that. So from a personal point of view, contributing, you can get a job easier. Yeah. Get the next job. For another point of view is from an engineer, you get to learn new things. I wrote my first driver and sent it out. So, oh, here it is. It's all perfect, whatnot. Everybody's like, no, this is wrong, this is wrong, this is wrong. And you ever heard of multiprocessors? I'm like, what? What is all this? And that's great. From an engineering point of view, I want to know better. I mean, the Linux kernel developers, you can never have all the best developers in the world at the same company. But when it's open source, we can all work, the best operating system people can all work on the operating system together. So the depth and talent of the people that are working on Linux is just amazing. Take advantage of that. I'll say the Rust developers that are working on Rust for Linux are core Rust developers. These people are really, really, really good. They maintain core parts of the Rust infrastructure. Take advantage of them. I mean, I'm learning so much from them. So from an engineering point of view, there's these people that are really out there and willing to help you and grow and as an engineer and learn different processes and learn different skills much better. I mean, I learned so much more working in the community than I ever did working at companies because you have better review process, you have more exposure to crazy corner cases that you hadn't thought of that, oh yeah, in the real world, yes, that would have been 1 in a million, but we do have to take that because we have 1 million boxes, 4 billion machines out there.
Plus, I guess that the more curious you are, everything is open in Linux. So I remember when I joined Uber, I was just amazed by the RFC process, and internally I could read all the RFCs, and I spent like a week or two just kind of reading and trying to take it all in. Linux is here. Like anyone, obviously it's overwhelming if you just start at once, but you can like target something, and so you can just even if you contribute little or even before you contribute, you could just learn. You can see how the changes are made. You can try to understand these things. Yeah,
I will say it's not the best learning operating system. There's really good learning operating systems out there. We're not this. That being said, I mean, people still write academic papers about it and all this stuff. We want to rewrite the scheduler or do all this fun stuff with it because it is a real world tool. I mean, I learned from Minix, and Linus learned from Minix, which was a learning operating system. And then we took those ideas and we made Linux with it. I mean, Linus did it way before me. But learning operating systems are great, but working on a real world Linux system is a little bit different. That being said, there's parts of the kernel that are very easy to get into for newbies. We have a whole section of code with really bad, crummy drivers that are the wrong coding style. They have the wrong formatting. They have just a lot of dead code. That's there for beginners to take up and take your first patch, fix out the spelling mistakes, fix the coding style, learn how to do this stuff. And there's a whole website, kernelnewbies.org is a wiki that has a whole bunch of stuff on it, how to write your first kernel patch, how to get involved. I've given old YouTube talks if you search how to write a kernel patch. I need to do a newer one. It's fun. I've gone to universities and said, here, I gave everybody a file that you're going to write a kernel patch for this file. It's like, what? Okay. And they do it. And by the end of the class, end of 2 hours, they send a patch off and they got to accept it. It's very simple. It's not a difficult thing to do. And we want new people to get involved because we don't know who's out there or what they can contribute. If they just want to do something for fun or do something for real. It's great.
Awesome. Well, this has been really interesting, and I just like to close off with some rapid questions where I just ask, and then you do what comes in mind. What's the most memorable patch that you've contributed to in Linux?
That I've contributed or other people?
What we've seen.
I've seen. So this is going to be about people again. Early 2000s, we were starting to get Microsoft was saying Linux is a cancer. We're all worried about Linux.
Oh, I remember.
Yes, I remember that stuff. We started getting some really, really good patches for some hardware that we really didn't know that well. That was showing some really good stuff. And it was like, this is really good. And we're like, where did you get this information? How did you know this stuff? Is this like somebody trying to sneak this in? And the person wrote back and said, here's how I found this. Here's how I tested it, how I did this. I'm like, okay, all right, we took this. And over time, we took all these patches over time. And then we have this conference once a year for all the maintainers. And you get invited to it. And we're like, oh, let's give them an invite because it was really good. And it was in Canada every year for a number of years for some reason. And they came and they showed up and he showed up and he's like, oh, sorry, I had to bring my mom because he was in high school. He was 17 years old. None of us knew. And he contributed. And it was like, okay, great. And it turns out he later went on to MIT and now he's a professor at Stanford.
Wow. So, yeah, all you see is an email address in Linux, right?
Yeah, say Adam so-and-so. It's like, okay, yeah, it's like that. I mean, it's things like that. That's good. Another one I'm really happy about is there's lots of drivers that have been sitting outside the kernel tree for many, many years, just because people never got them upstream and whatnot. One of them is the subsystem to handle Braille keyboards. Mm-hmm. So Braille displays.
Yeah.
Just feel that those are outside the tree. I and a couple other developers worked with those people and got them in the tree and got them working, and now they're shipping with all devices. So we made sure that these people who were always having to patch this out of tree stuff because these devices only needed for a very tiny subset, but now it's available for everybody. I'm very happy to see that happen.
Wow.
So,
And I guess this goes back to Linux of what you said, why companies will contribute a few developers per year, because now when you take Linux, you get an OS, for example, that also has Rails support. Like, that itself, like adding it to an existing product or if you built an OS, like that itself would be a massive undertaking.
Yeah. So now it supports all the devices out there. So.
Awesome. What's your favorite programming language?
It's still C.
Still C.
I mean, I've been doing C for 30 years every day. So yeah, C. Yeah. I've been doing a lot of Rust lately. Rust, I feel like I'm able to write really sloppy code and it works. I don't feel like I have to be as precise as C, which is, I don't know if that's good or bad.
And what's a book or two that you would recommend reading?
The old Code Complete book was a really good one. That was a really good one. It taught me that coding style matters. It doesn't matter what the coding style is. It's just a generic set coding style matters because our brains work on patterns. And as programmers, we're reading patterns. And when the pattern's the same, the metadata goes away and we can see the logic easier. Code Complete is aged a little bit weirdly. If you look at the first book, it has a lot more C examples and whatnot, but it talks about the basics behind programming, all that stuff. And that was a really, really good book. On the flip side, another really fun one that's really tiny, Programming Pearls. And it's like bit fiddling and cute little algorithms and neat stuff like that, which surprisingly we still do today. We're talking about adding parity functions in a common way. And everybody's like, no, if you do it this way, you do it this way, it'll be faster. And this. So we're still messing with these things that people have messed with for 40, 50, 60 years. And these things still matter. And they matter to people because cycles matter and power matters and things like that. So between those two, those are my favorite ones.
Well, this is awesome. This has been such an interesting and, like, for me, just really educational and eye-opening chat. So I'm glad we did it.
Well, thanks for having me.
I found this episode to be a really interesting one about Linux. I'm still amazed that an open source project managed to become the most widespread operating system in the world, despite not being a commercial business. It's such an interesting and inspiring project. You can find Greg on social media as linked in the show notes below. And if you'd like to try your hands on contributing to Linux, visit kernelnewbies.org. For more deep dives related to backend engineering, check out the Pragmatic Engineer articles linked in the show notes below. If you enjoyed this podcast, please do subscribe on your favorite podcast platform and on YouTube. This helps more people discover the podcast, and a special thank you if you leave a rating. Thanks, and see you in the next one.